Let's look at balancing equation. It's one of the most difficult thing that a student faces in chemistry. That's what my students tell, but it's quite simple actually. If you use this method, it's very simple. Let me show this example. So we have CH4, O2, CO2 and H2O. I have a table. What I'm doing is I'm writing the reactants and the product, right, in the upper row. Along the first column, we have carbon, hydrogen, oxygen. These are the atoms that is involved in the reaction. I'm listing them out. Now, I'll count. That is, how many atoms are there in CH4 of carbon, hydrogen, oxygen. So in CH4, there is 1 carbon, 4 hydrogen and none of the oxygen atoms. In O2, there is no carbon, no hydrogen, but 2 oxygen. In CO2, we have 1 carbon, no hydrogen, 2 oxygen. And H2O, we have no carbon, 2 hydrogen and 1 oxygen. Now, let's take up one of the most easiest numbers over here. Like say hydrogen, 4 and 2. See, what is balancing equation mean? The number of atoms on the LHS has to be equal to RHS. So how can I make this as 4? I'll just multiply with 2, as simple as that. So I'll multiply this with 2. So you can write this in pen and then you can write this in pencil, because you might have to erase it. For most of the case, this is enough, but sometimes you have to go back and erase things. It's like playing Sudoku, literally. So if I multiply this with 2, right, then it becomes 4. Multiplying this with 2 means by default you are multiplying H2O with 2. Only then you will have 4 hydrogen, is it not? Does it make sense? H2O I'm multiplying with 2, only then the hydrogen becomes 4. If I'm multiplying H2O with 2, and this also will become into 2, because there are 2 oxygen, is it not? I'm changing the scenario. So here 2 plus 2 is equal to what? 4. But here it is 2. The number of oxygen on the LHS is lesser than RHS. So 2 plus 2 is 4. So I'm making this as 4 again. And here nothing else get affected. And let's see now, 1 and 1, 4 and 4, 4 and 2 plus 2, 4. It's balanced. Again, let me take up one more example. It will be a lot clearer. So I'm writing the reactants and the product. So this is, you can see it's a pretty complex example. Next step is list all the atoms involved in the reaction. Then look at how many atoms are involved. So in this case, it's 1, 2 nitrogen, 6 oxygen. Again, please understand this. You go back to basics to understand this, guys. There's no K and I. So here you have 1 and 1, right? None of this. That's all. It's a very simple thing. I'm just mapping them. Here it is 1 and 2. And here you have it to be 1 and 1 and 3. Right? I have mapped everything. Now let's take the most easiest. So you have oxygen to be 6 and 3. So let's start with that. I'll multiply this with 2. If I have to multiply this with 2, if I want to make this as 6, by default I have to multiply this with 2. Right? Only then this becomes 6 atoms of oxygen. If this is 6, we are done. But if I'm multiplying this with 2, even this has to be multiplied with 2 and this has to be multiplied with 2. Right? By default. If I have to make this as 6, right, I have to multiply 3 with 2. That is indirectly KNO3 has to be multiplied with 2. Does it make sense? If KNO3 is multiplied with 2, by default, your nitrogen, right? This 2, that is your potassium, has to be multiplied with 2. Has to be multiplied with 2. Right? Only then 2 will be equal to 2. Here 6 is equal to 6, 2 is equal to 2, 1 is equal to 1. But here there is 2, but here it is 1. So I have to multiply your iodine with 2. Because I multiply this with 2, this has to be multiplied with 2. My bad, actually I had resolved it that time itself. I forgot to do it. Let me redo this. It will be a practice, right? Oh, okay. Let me not do that. Let me do this. So what is the process? We'll write the reactant and the product on the top. PbNO3 twice, and you have Ki, your potassium and your iodine. Then again you have your PbI2 KNO3. So we have your lead, nitrogen, oxygen, potassium and iodine. Okay. Now then we'll write the number of atoms present in this particular compound. Nitrogen, there are 2 of it. Oxygen, there are 6 of it. No potassium or iodine. Here all of this I'll ignore, and here this would be 1 and 1. Here it is 1, ignore 2. Here there is 1, 3 and this one. Okay, so potassium is 1 over there. So let's start balancing. Let me pick up oxygen. Oxygen here, this is 6, this is 3. So I'll multiply this with 2. By default, this entire thing has to be multiplied with 2. And so when I multiply all of that with 2, by default, this will increase by 2. Okay, nitrogen will increase by 2 in the product side, and potassium will increase by 2. Because potassium is increased by 2, by default I have to multiply this with 2. And Ka also by default has to be increased by 2. If Ka is increased by 2, iodine also has to be increased by 2. Take a second, think about it. All of this is chain reaction in some sense. Okay, one is followed by the other. Now let's see if things are balanced. So we have iodine 2 and 2. Okay. Potassium 2 and 2. Okay. Oxygen 6 and 6. Okay. Nitrogen 2 and 2. Okay. Lead 1 and 1. Okay. So basically this particular chemical equation in a balanced manner should look like the following. 2 times of, right? And then PbI2 plus 2 times of KNO3. And that's that. And herein you have CH4 plus O2. Okay, here I have to multiply with 2, my bad. 2 times of O2 giving us CO2 plus 2 times of H2O. These are all number games. Okay guys, see, one thing that you might miss out is when you balance one of the compound, don't forget to multiply the actual compound with that particular number. Again, I'll repeat, if you try to balance one particular atom, my bad, I should have told atom. If we have to balance one particular atom, when you do that, you go back to the compound and multiply with that number. Again, do it with pencil, because sometimes it's not 2, it might be something else. It might be 6 or maybe 12 or things like that. It can change. So when you start off with that, then once that happens, by default, all the atoms within that compound has to get multiplied, increased by that quantity. See, this is basically your ratio and proportion, to be honest. What we are using is ratio and proportion. If I tell 2 times of KNO3, by default, you have potassium to be increased by 2 times, nitrogen also increases by 2 times, and oxygen O3 increases twice. That is, it becomes 6 oxygen. It's a ratio and proportion. So if you have that sense of ratio and proportion, this becomes very simple. Okay. Throughout this chapter, we'll be doing this. I'll be using the same set of tables and everything. So you'll get a lot of practice. But yeah, if you are able to understand all the things in this video, in the next set of videos, whenever we get a chance to balance, you pause the video and you balance it yourself first.